Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 9 in our series on the design of everyday things by Don Norman.
Hey, John. How are you doing?
Hey. I'm doing good. How are you?
I'm all right.
Nice. Want to talk about mistakes?
I want to talk about mistakes. Have you ever made a mistake? Because I haven't.
Man, I make mistakes. It's like my life. It's just mistakes. Like the entire thing. It's one big mistake. By my parents.
See, now you're exonerated from any responsibility.
Yeah,
absolved.
Exactly. That was the original sin, so everything I'm doing is just icing on the cake.
Yeah. So we talked about errors last time, mistakes, slips.
Yep.
And now I think we're just gonna dive in even deeper. Continue to go through.
I really like the section where he classified the types of slips. I just found this really interesting some reason.
What does he say about slips?
Yeah, so I mean, firstly, like the slip is the thing where you're trying to do something and you just straight up do the wrong thing. You know, you're making a coffee. Yeah. You make the coffee, you get your milk out of the fridge, pour it into your coffee cup, and you accidentally put your coffee cup back in the fridge. That would be a slip. So there's different types of slips. The capture slip is where instead of doing one thing, you do another recent thing. And I think actually the coffee cup example is kind of an example of the capture slip, because you're like dealing with, two objects. You're like getting something out of the fridge, and then you're just putting the wrong object back in the fridge. I don't know. Do you think that's an example of a capture slip, or am I reaching here?
I almost think that that's more of a something similarity slip. Like
it
the
is.
Object
description similarity slip.
Description similarity. Like in your visual field, given that you're distracted, like those are similar enough. It's like, all right, this is roughly like a cylinder shaped thing on my counter. Like, let me and like, if you think back to like affordances and things like that, it's like the affordances are basically exactly the same. And so, but one thing that actually just happened to me, so I am using this, I'm recording this on Descript. It's a project, it's a piece of software that I work on, I develop for. So when I went to log in to the app, so I go to log in, you use Google Auth. I'm presented with my work account and I'm presented with my personal account. And there was no possible way that I was going to click my personal account, because probably 10 times a day I log into my work account.
Yeah.
And it's just like the starting parts of that are exactly the same, and you just need to like move your mouse to much smaller, like a different part of the screen. And it's like, unless I'm paying very close attention, specifically because I'm embarrassed that I just clicked on the wrong account to log in. So does that seem like it aligns with slip, or what is it? Capture
slip. Yeah. So I think that's a good example of a capture slip. So then there's this description similarity slip that we just touched on, which is basically something can be described similarly, like throw your dirty clothes in the laundry, but you accidentally throw your dirty clothes in the toilet, because it's kind of like, it's a similar type of action, like you're taking a bundle of clothes and you're kind of throwing it into a hole. So you just kind of throw it into the wrong hole. So again, I think the milk example is also a description similarity slip. Then there's something called a memory lapse slip, which is, I think this one is just where you kind of like forget something, which, hence the term memory lapse. And the example he gives is where, let's say you're making copies of a document and you just like leave the document in the copy machine. That would be a memory lapse slip.
I guess the way to think about this is like, it's like the plan almost certainly included a step to take the original off of the Well, actually, so then now this is an interesting point because I guess depending on like the particulars, you could have never been thinking about the fact that you needed to take the original off of the glass, or you could have just like forgotten to do that, even though you were like aware that that was something you needed to do. So it feels like kind of a gray area.
Yeah,
because it's all
definitely.
subconscious, right? Like when you're making a copy, you're not like you don't have the like steps. Maybe this is why you need a checklist.
Yeah, man. We should have checklists for making copies. That's the stage where I'm headed. That's like the quality of my brain these days is I need a checklist for making copies of a document.
But man, I think memory lapse slips. This is my bread and butter.
This one's
My
huge.
slip all the time. Were you going to say something?
Yeah, I was just going to mention he gave another really interesting example because I actually remember this from when I first got my like ATM card. The way ATM machines used to work is you could forget your card in the machine. Like you could just, you put your card in, you type your PIN or whatever, you get your money, and you just leave your card. And it's this horrible situation. And I actually had left my card in an ATM machine before. And these days, the way it works is before it dispenses your cash, it's like, take your card. And, going back to what we were discussing in the last episode, like these guardrails, that is a very good, very well-designed guardrail, preventing a very easy-to-make mistake. So I am supportive of that particular one.
We need some sort of like brain finalizer or something like where, you can, before you do an action, because I'm a big believer in like you do the like end thing. Like whenever this is kind of a dumb example, but like whenever I type a brace or a parenthesis, like I always like to type the matching closing paren at the same time because it's like it's kind of similar because you don't like it, or it ties back to what I was just saying where it's like there's going to be a bunch of junk in between here and I don't want to have to remember and figure out like which syntactic layer this matched paren is going to have or curly brace is going to have to correspond with.
Oh yeah, no, it's a pro move to just type, both brackets and then cursor left into the contents. And like these days, I feel like a lot of IDEs will automatically like type the right side of something, and that actually
which I actually hate.
Yeah, because it's like I don't know, so much my fingers already have buffered to like type the thing, so I end up like typing it twice, and then I have to delete one of them, and it's just a pain in the butt. So
I do think some of them have like detected that now, which is even more absurd, where it's like, oh wait, okay, so we're gonna add a new one, but then if the user types the same character, we're gonna like
absorb it.
Collapse them or something. It's just like, all right, just chill out. Like, I'm fine. I'll type this other character. Like, the characters are right next to each other. It's a quick, like, it's a really quick operation to type the other one because they're matched.
Yeah.
It's like,
how much engineering time is lost from people just trying to save keystrokes? It's like, let's all just type. Let's all just get better at typing. Remove all of these, bells and whistles, and there will be a lot of boilerplate and we have to type it, but that's okay.
Well, I mean, AI is just going to start writing everything. So
right. Yeah. We're only going to have a job for another 2 or 3 years. So, but there's one more type of slip that I want to talk about, which is the mode error slip. And this one I actually love. Basically, what this one means is there's different states of the universe, let's say, where the same controls have a different meaning. So I think this goes all the way back to mapping, where you have like controls that map to some output or some action or something. And imagine a state change where that mapping changes. Those same controls do different things. And he gives a very an example which I thought was tragic, like this Airbus plane crash, where there's a bunch of important indicators on a plane, obviously. And it sounds like, from my interpretation of this tragic event, is both the angle of the plane, like basically the pitch, I guess, and the velocity would be shown on the same display under different circumstances with 2 digits. Like they would be shown in the same, with the same number of digits, which just sounds like it sounds insane to me.
Yeah.
But I'm sure it's one of those things where it sounds completely insane in hindsight, and at the time they were like developing this user interface, like it might have made sense, or maybe there's some reason why pilots would understand it that way. But yeah, I mean, basically the pilots thought that they were decreasing their like velocity, and really they were just pointing the plane straight at the ground. And I found it to be tragic and just a crazy example of this type of slip.
And so your point is the display didn't have the capability to indicate like units or anything like that. It was just like 3.3, and like in some circumstances it was degrees, and then in other circumstances it was like feet per second or something like that.
Like if you're cruising at 30,000 feet or something, it would just say 30. It might have had, I don't know. I don't remember if he mentioned if it had like a unit on it or something, but I remember him calling out that it was 2 digits. So like the same, you look down at the thing, you see a 2-digit number, you look down again, you see a 2-digit number, but it actually means 2 different things. Like it just feels like a recipe for disaster.
Yeah.
That is the classification of slips. And he gave a separate classification of mistakes, but I just did not, I didn't write them down in my notes. So I'm wondering if you recall them.
Yeah, so we can go through those. So first off, we have rule-based mistakes. The situation under which a rule applies is like mistakenly, you think a rule should be invoked, but like you're actually wrong in that regard. So
yeah,
and then the other thing is like rules, like the rule itself is wrong. Like someone has laid down a rule, like if this, then that, but then actually that's not necessarily always the right thing, or
okay.
And then
did he give examples of these, by the way? Because I'm like, the way my brain functions is I just like need concrete examples of things.
Yeah, so he goes into an example where a band accidentally set the ceiling acoustic tiles on fire by using flares in their pyrotechnics display.
Jeez.
And, that would have been bad enough by itself. But so then there was a rule-based error that was layered on top of this, which was that the bouncers or the guards at the club were actually stopping people from leaving the venue because there was a rule which was like, people try to leave without paying for their drinks, so don't let them do that. But
right.
The rule didn't accommodate for like emergency scenarios, which just like, and I'm sure they figured out eventually like we should let people leave, but like it was just the kind of thing where it's like you have this underspecified rule and they start following it, and it causes to excess death,
Yeah.
So
I remember
that's
that.
an example of a rule-based mistake.
So depressing. I feel like there's other examples of that I've read and heard about with dealing with crowds, and because a common thing that can go wrong with a crush. I remember reading about an example where there was like a magic show and there was a ton of kids in the audience. This is like a super tragic example. And there was a door that was like propped open, but it was like propped open in such a way that you couldn't open it any further. Like it was wedged against something. And basically what happened is all these kids were either trying to get into the venue or out of the venue. I can't remember. And they couldn't exit the door fast enough because of this propping. And so there was a crush, and a lot of kids were killed. It's just a very depressing event.
Oh my God, that is just. And again, I mean, this probably goes back to guardrails, where maybe that door was propped open because, they probably wasn't supposed to be propped open, but there was something that they needed it to be open for, and there wasn't a good, safe way for them to do that.
Yeah, I bet it's similar to the bouncer thing where they had they're like, let's prop this door so that people, can't leave too quickly or whatever, or can't enter too quickly maybe. And it just backfired because people don't, they make decisions and they're not accounting for worst case scenarios, and then it happens, and everything goes wrong.
So the other thing that he says is knowledge-based mistakes. And this is another hard one to pin down because it's kind of saying like there's no formal rule here that's specifying this or like a skill. So literally it's just your assessment of the situation and your decision in that circumstance. It's like you only understand in retrospect that it was a bad decision. Yeah. And so, he basically goes on to say he doesn't give any examples of this, but he does say, like, from a design perspective, the best thing you can do is try to provide all as much of the relevant information about the situation as possible to the user. So it reduces the likelihood that they're forgetting some important detail.
Right.
And then memory lapse mistakes. And so this was also a slip where, there's an interruption in like your formulation of the plan, and you actually like forget an earlier part. Like you go to start doing something and then you forget the full context there.
So this would be a case where you're writing that checklist for yourself, but you forget a step in the checklist, which is why there should be a master checklist that you just copy.
Yes, exactly. So yeah, I think those are the high level the categorizations of mistakes as compared to slips.
Love it. He went on to talk a lot about why these things happen. And I found there was a bunch of sections late in the chapter that I thought were super interesting. He talks about social and institutional pressure, which is something that I do think exists in our industry, like in the software engineering industry, where what I have found, and I'd be interested in your take on this, is knowledge and sort of like intelligence is currency in our industry. So an important thing to be doing is to be exhibiting knowledge and, showing that you have intelligence, almost like a peacock with their feathers, and also preventing people from, realizing that you don't have knowledge, sort of like protecting your, basically not being vulnerable.
Yeah.
And I'm sort of wording this in a very extreme way. Like, obviously this is a spectrum. And it's why I like cultures where vulnerability is normalized, because I do think it is very dangerous to have a culture where people are deathly afraid of like saying the wrong thing or making mistakes because they just won't ask questions, and basic misconceptions can happen. And he talks about, and also I think those cultures also tend to very much favor like, the senior or like more vocal people in the room, because maybe the junior people are like afraid of, saying the wrong thing, getting trampled. And he talks about a KLM disaster, which is another flight disaster where the pilot of the plane was doing the wrong thing. Like he was crashing the plane, and the junior co-pilot spoke up and said, "Hey, I think this is wrong. I think you're making a mistake here." And the pilot just totally overrode the guy and crashed the plane. And obviously another. I feel like this episode is very tragic, but yeah, just another very tragic example. But also an example of why that type of culture is so dangerous.
Well, I think there was another. I won't know the specific details, but there was another case relatively recently. I think it was a Korean pilots. Basically the same situation happened. Yeah. But they're apparently in. I don't know if it's in Korean culture or if it was in the culture of this airline, but you do not question your superior, in that, or in their culture. It was not okay to question what the superior pilot was doing.
Right.
and the junior pilot was like kind of knew that something was wrong, but he didn't have the the cultural ability to even propose that. And
Right.
and it led to it was some crash. I mean, I'm sure, but I don't remember exactly what the outcome was. But I think exactly to your point, it's like it needs to be okay for junior people to like say that they think something is wrong,
Exactly.
because
exactly.
either they're wrong about their assessment of the situation and they should learn about it, or the senior person really is wrong.
Right. I think it's also, I think there's a flip side to this too, where a senior person needs to be able to say, I don't know. Like,
Yeah.
I'm not sure. Because I'm sure that in those events, or I guess I'm not sure because we'll never know, but I wonder if there was like an inkling of a doubt in those pilots' minds that, am I doing the right thing right now?
Yeah.
And I think that culture cuts both ways, where junior people are too afraid to call out their senior counterparts, and senior people are almost too afraid to like show weakness.
Yeah.
So they're kind of like, I'm just going to follow this through to the bitter end, even though I have this doubt in my mind. And yeah, I think both of those are very dangerous. Another, I think, really, really, sad but good example of this is the Chernobyl incident. And I'm kind of basing this off of the television show, which who knows how, true, like who knows how well that followed the actual truth of the incident. But it seemed like a large part of what made that problem worse was people just afraid to tell each other that they screwed up and that there was a serious problem happening. There was all these delays in actually communicating the full scale of the problem.
Yeah.
To more senior people in the Soviet Union. And, it's, we need to be able to normalize making mistakes and normalize not knowing things. And it's just very important.
There was one example where he talked about people being on, I forget if it was an oil rig or something. He did an assessment of this business, and he was saying, I can give you these different rules about that will reduce most of your mistakes, but you're going to need to give up this Superman mentality that the people that are kind of on the rig are infallible and can't ever make mistakes, because counterintuitively, that's actually leading you to these worse outcomes. So I think it is so important that people have the humility to say, oh, something's going wrong. Like, we need to, I don't know, I fucked up or something. But
yeah, I also think it's powerful for a senior person to say, like, I don't know, in front of junior people. I think that can be, this sounds silly because it sounds really dramatic, but I just think it can be setting like a good example for, people who are more new to a team and just realizing that, like, oh, this is the culture. Like, it's okay to just not know something or do the wrong thing. Another section. Oh, sorry. Go ahead.
Well, yeah, just a quick point on that. It's like, I think there can be something weird that happens where you have a person who is willing to admit their ignorance about something. And that actually is really good for them learning a ton of stuff very quickly. They learn about everything because they're willing to admit their ignorance. And then other people who know what they're talking about teach them. So then you wind up with a person who knows a ton of stuff. So like, and then you have a junior person who comes to them with questions. And as far as as far as their perception goes, this person knows everything.
Right.
Every question you come to them with, they are giving you like a really thorough answer to. And it's not because that person isn't willing to admit their lack of knowledge. It's just because their domain of knowledge completely encompasses the questions that this junior engineer has lobbed in their direction. So, so I think you can kind of get this sense like, oh, like I can't say, the senior engineer is never saying they don't know anything. Like, I need to always have an answer.
Right.
And, but I don't know. So I don't know if the resolution to that is to say you don't know, or just to try to convey your knowledge with some inkling of of self-doubt. I don't know. Maybe that's silly, but like,
Yeah. No, I mean, you raise an interesting point because, I think it's really valuable when senior people can sort of tell junior people like, oh, the way that I learned so much in this organization was by being curious and sort of admitting that I didn't know things and being proactive about, learning new things. And, that can, I guess that can be more difficult when you sort of like already have learned all of the important questions. So you just look like this infallible, godlike creature.
yeah.
But yeah.
But you were going to say something else.
Oh, right. I just wanted to move on to another couple sections in this chapter, which I thought were interesting, which was basically mistake prevention. And he mentioned a few techniques.
Never.
Yeah.
Just stop trying.
Just be better. But he mentioned a few interesting techniques that I think were both, I'm pretty sure they were both from Japan. And I want to say they were both from Toyota. And they're called Jidoka and Poka-yoke, which I just love these names. But Jidoka, which I think means automation with a human touch, is basically, and yeah, I only wrote a couple of notes for this, so feel free to fill in the blanks here, but like you get punished for not reporting errors. Like you basically form a culture where you're normalizing reporting errors, and you probably get a lot of false positives, like, error reports that aren't actually errors, but you probably also avoid a lot of errors that are truly errors. So I thought that was very interesting. And also Poka-yoke, which this one I found even more fascinating, which was basically like you jerry-rig things to try to prevent mistakes. And the example he gave was like, if you have a switch that does something very serious, you put a cover over it. You have one of those like little cover flaps that you have to like lift up before you can hit the switch. Or like if there's a lever where you can like accidentally push it too far to do the wrong thing, like you put like a little wooden block there to like prevent, so you have to remove the block in order to actually push it further. And
Right.
I thought those were both really cool things.
One question I have with Jidoka is, how do you evaluate when a worker didn't or knew about a potential error and didn't report it? Like, how do you do that?
Oh, that is interesting.
I guess when something bad happens, you try to find maybe you just do interviews or something.
Yeah. You'd almost need to know every point where someone could have seen that like an error was going to happen, and yeah, basically ask them like, hey, why didn't you say something?
Maybe it's just enough to say that you would be punished if you saw something wrong and didn't do anything about it. And you don't even actually need to be able to follow up on it. And then anytime someone thinks something could be wrong, it's like, oh, if someone found out about the fact that I knew that this was happening and I didn't say anything, I'm going to get in trouble.
Yeah, exactly.
And yeah, I believe in the error proofing. And I think, yeah, it's probably for the best. I keep on thinking back to the fact that my Mac warns me every time I download a program from the internet, and I'm like, I'm okay, I got this. Like, you probably don't need to warn me in that case, like the little block over the switch, which is the switch is like install a program from the internet. It's like, all right, Mac, like
you just want to tear that block off.
I'm good. Can I rip this off? And no, it's not possible. But but the other part of me thinks like it's probably better to have that, like have a little bit of annoyance.
These are questions I constantly ask myself because like, just as an example, my organization has these tests that have to run. Like we have a fairly large system, so it takes a really long time to build our system and a very long time to like run the full tests for our system. And I am constantly asking myself, like, are these tests actually
adding value?
Yeah, I mean, I'm sure they're like adding value. Like I'm sure they're occasionally preventing issues or whatever, but are they adding enough value to justify their cost is, I think, the key question.
Well, It feels like making those tests faster should be like whoever's responsibility those tests are, like it should be a really high priority to make them run as fast as humanly possible. Because it's like if every engineer in the system is running them like for, I don't know if it's every PR that you've merged or what, but or
yeah, I mean they are run all the time, and they're part of a lot of like normal workflows. So yeah, I mean I agree. I think improving the speed of them is super high priority, but it's tricky if your system is so big. It's just tricky because it's big. You can't really. It's like unless you're breaking the actual system down into like separate parts that can kind of function independently. Like it's just
you need to fix the system, and I do think. I don't know. This is probably we can cut this, but I do feel like sometimes unit testing can like lead with like you're wind up with a design that has like very strangely like very. It's like units of functionality that are very small and like maybe don't make a lot of sense, and you basically broke it down that way so you could write a test for it. And like,
yeah,
I think that's an anti-pattern too.
Definitely. Yeah, and I definitely have seen cases where, testing the code causes the code to be worse. And I just really don't like that. So there was one final thing that I wanted to talk about with this chapter, which was the Swiss cheese model of how errors lead to accidents. Which I like this because he had this image of like a block of Swiss cheese and basically like a rod kind of going through the block. But the basic premise here is like major accidents usually happen because of a series of errors that kind of all line up. And, you can imagine a block of Swiss cheese where you can shove like a pencil, through the whole block because there's one hole that just kind of goes all the way through. And the reason this model is useful, or one of the reasons, is because one way of preventing major accidents is to kind of move the pieces of cheese around so that there's not a hole that goes all the way through. Because you're going to have accidents. Like there's no way you can design a system, or I'm sorry, you're going to have errors. There's no way to design a system that's going to be error free, but you can avoid major accidents by trying to prevent errors from kind of stacking up on top of each other.
Interesting. Yeah. This almost feels like more useful in like an investing like sense, where it's like an exposure to risk, where it's like you have these like correlated risks where actually you have all of your asset classes are could tank in value simultaneously from a particular kind of failure. And I don't know, like, does he have an example of like what moving the piece of cheese means, or like
I don't know if he's...
How do you move the piece of cheese?
So I don't know if he said this example or I just wrote it in my notes because I was trying to think of an example, but he did give... So he gave an example of the Swiss cheese happening, or the rod going all the way through, where it was yet again a plane disaster where like there was fog, there was delays on the runway, so pilots were making bad decisions because of delays. And then, there was pilot mistakes. So like all these things kind of stacking up in order for this truly terrible accident to happen. And I wrote down, you could have a policy where like if there's fog, things need to be double checked. Like you just can't do certain things. And that might be a way of kind of moving one of the piece of cheeses.
So I have the steps here. So he says, add more slices of cheese.
Nice.
Reduce the number of holes or make the existing holes smaller. Alert the human operators when several holes have lined up.
There you go.
That is a very interesting idea. I'm trying to think about this is something that is making my brain light up a little bit, because I work on this collaboration system, and it's like there's so many moving pieces to it, and it's like we have a case where collaboration really breaks down. It's never just one thing. It's like it's this concert of effects, and so it's always hard to take the like melted cheese and like pull it apart and be like, okay, like where were the holes here? Like all I have is the, they tell me like, oh, collaboration was horrible. And it's like,
Yeah.
It's your job to kind of like do a little bit of like technological forensics and be, figure out where things were falling down. So
Yeah. He kind of alludes to this where he talks about I think it's the NTSB, which is the organization that does the forensics into like why a plane accident happened. And he talks about how that process needs to be slow and very rigorous. And, because one complaint people have about these NTSB investigations is they take years.
Take forever. Yeah.
But there's a reason they take years. Like they really need to be like extremely methodical with how they go through how the accident took place. And that process yields great results because you can figure out how to move these pieces of cheese around or put like maybe you put like a American slice into the Swiss cheese block that is just impenetrable.
No holes. Yeah.
Or some Velveeta. Just shove some Velveeta in the holes.
All right. Well, with that image, maybe we'd call it. Was there anything, any other nuggets of cheesy wisdom you have to slather all over our users?
Oh man, well, when you put it that way, no, there wasn't really much else that I really wanted to talk about. This was a very good chapter. It covered a lot of material. There was definitely things that we didn't talk about, but I think those were the main things I wanted to discuss.
You got to read the book. You got to buy the book.
Exactly. Buy the book.
That's the only.
Put money in Don Norman's pockets.
This one was good. This was a really good chapter. I feel like we've leveled some criticism at him before, but I felt like this was peak Don. We kind of knew this. He was teasing the error chapter for a while.
Oh
so
yeah. He's in true form in this chapter.
It was a pay off. All right. Well. Okay. So let's see now for next chapter. It's called Design Thinking, Chapter 6, Design Thinking.
Okay.
So,
Awesome.
well, I'll see you there, John.
See you there, Matt.